I want to talk today about integration in the NMR spectrum. The integration in an NMR spectrum represents the area underneath each of our peaks. So I've got 1, 2, 3, 4, 5 peaks here, and the integration gives me the relative area under each of these peaks. So the integration is represented by these numbers here. So what this tells me is that this peak is 0.4, this is 0.38, 0.43, 0.42, and 0.63. That's the relative area under each of these peaks. So my ratio is 0.4 to 0.38 to 0.43 to 0.42 to 0.63. Now obviously I can't have 0.4 of a hydrogen or 0.63 of a hydrogen. This is just the ratio of them. I have to translate these ratios into whole numbers. And there are a number of ways that we do this. One of the ways that we will do this often is to divide them all by the smallest one. So I'm going to divide all of these by 0.38 because that's the smallest number there, and see what happens. So when I do that division by 0.38, I get 1.1 to 1 to 1.1 to 1.1 to 1.67. Now these first three, it would be reasonable to round them all to 1. This one though, 1.67, it's too far from 1, too far from 2 to round. We need to do something else. What I'm going to do next is I'm going to multiply this by something that would give me close to a whole number. If I multiply this by 2, I get about 1.32, but if I multiply this by 3, I get 5.0. So that's what I'm going to do now. I'm going to multiply everything by 3. When I do that, I get 3.3 to 3. This should be 3.3. I typed wrong by mistake. To 3 to 5. And that's acceptable to round these down to 3. So the actual ratio of hydrogens in this molecule is 3 to 3 to 3 to 3 to 5. In other words, this peak right here has 3 hydrogens. This one right here has 3 hydrogens. This one has 3 hydrogens. This also has 3 hydrogens. And this one, whatever it is right here, has 5 hydrogens. It's important not to confuse the integration with the splitting. So this has 3 hydrogens, but the doublet tells me it's next to 2. Likewise, this has 3 hydrogens. The doublet tells me it's next to 1 because of the n+1 rule. This has 3 hydrogens. The triplet tells me it's next to 2. Remember the n+1 rule. 3 peaks, 2 neighbors. Don't confuse the integration with the splitting. Okay, let's look at one more. It's this NMR spectrum right here. And you can see that the ratio is 0.51 to 0.52 to 0.75 to 0.76. So I'm going to start the same way I did last time. I'm going to divide everything by the smallest number. This time when I do it, it works out very nicely without having to do anything else. You can see that when I divide everything by 0.25, I get a ratio of 2 to 1 to 3 to 3. In other words, this peak right here has 2 hydrogens. Oops, typing error. 2 hydrogens. This right here has 1 hydrogen. Then I get 3 hydrogens and 3 hydrogens. So the ratio is 2 to 1 to 3 to 3. And now what we would do further is we would want to think about this in conjunction with the splitting. So right here, for this peak right here, I've got 3 hydrogens next to 2. And let me write that out. 3H next to 2. 3 hydrogens with 2. And actually I made the same mistake again that I made earlier. A doublet tells me I have not 2 neighbors, but 1 neighbor, because it's the n+1 rule. 2 peaks, 1 neighbor. So I have 3 hydrogens next to 1. And we would do the same kind of analysis for all of the other peaks until we had pieces that we could put together to find the structure of our compound.